Unit circle coordinates. When you look at a completed unit circle, it seems like a lot of information and it might feel overwhelming at first. But what I want to tell you is that unit circle uses only three fractions: 1/2, root 2 over 2, and root 3 over 2. If you want, you can think root 1 over 2, root 2 over 2, root 3 over 2. Wherever root 2 over 2 appears, it's independent. That's the only thing that you're going to see in that point. Now, half and root 3 over 2, they appear in pairs. So it's important to know their relative sizes. 1/2, we all know, is 0.5. Root 3 over 2 is about 0.866. So root 3 over 2 is bigger than 1/2. So that's what I want to write here. Root 3 over 2 is bigger than 1/2. And that information we want to remember. So here is how you would construct the unit circle. So once you're given the unit circle, you know that the center is at the origin and this unit circle has radius 1. So you can get these 4 points on the axis. This is 1, 0, that's 0, 1, that's -1, 0, and that is 0, -1. So once you have these 4 points, you want to build these lines that go in the northeast, southwest, northwest, southeast directions. So if you're thinking this is east, northwest, south, then this is northeast, that's northwest, this is southwest, and this is southeast. Now the coordinates of these points, so I have drawn those 4 directions in green. This green point has coordinates of root 2 over 2, root 2 over 2. It was that middle fraction. And that's what you will see for all these 4 points. Now, some of them will be negative. But the magnitude is all going to be the same, root 2 over 2. But in the second quadrant, your x coordinate will be negative. So be sure to put a negative for the x, positive for y. Then in the third quadrant, both x and y are negative. In the fourth quadrant, it's positive and negative. So that's how these 4 coordinates will be different. Now, after you have drawn those 4 points, you want to draw lines that are 15 degrees on either side of those middle directions. So in the first quadrant, then this is going to be 30 degrees and 60 degrees because we are going 15 degrees less and 15 degrees more. In the second quadrant, it would be 120 and 150. In the third, the middle one was 225, so it's 210 and 240. And then in the fourth, it would be 300 and 330. Now, for those 8 points that we have, 2 in each quadrant, the 8 new points, it's the combination of those remaining 2 fractions, 1/2 and root 3 over 2. And here is the important thing. If this point has come closer to the x-axis. Now, the green point was equally inclined to both x and y, so that's why it has the same coordinates. But if you are coming closer to the x-axis, then x coordinate will be more and y coordinate will be less. That's why you will write root 3 over 2 and 1/2. And that's how you would fill these 4 points. And I've drawn them in blue. So they all have the magnitudes root 3 over 2, 1/2. And then you will supply the negative signs. Now, similarly, when you go closer to the y-axis, I've drawn them in red. You can see that it's the y coordinate that's going to be more, so x will be less. So this time it would be half root 3 over 2 for these 4 points. And then you supply the negative signs wherever they are needed. And that's how you build the unit circle. Now, why are those coordinates important? It's because you can define your trig ratios in terms of those coordinates. So sine theta is defined as the y coordinate, cos theta is defined as the x coordinate, and tan theta is defined as the ratio y over x or sine over cos. So with that, if you want to know what is, say for example, sine 120 degrees, then you just look at the y coordinate and say it is root 3 over 2. If you want to know what is tan of 315 degrees, then you take y coordinate, which is negative root 2 over 2, and divide by the x coordinate, which is root 2 over 2. So they are opposites, the ratio will be negative 1. If you want to know what is cosine of 270 degrees, cosine is defined as the x coordinate, so it is 0. So knowing the unit circle will give you the trig functions for all these nice angles, 30, 45, 60, 90, and so on. You don't need a calculator for any of these nice angles. And that's the idea of unit circle. Hope you learned it. If you want to a little bit slower video where all of this is built from scratch, check my other video. It's titled Unit Circle. In this one, I wanted it to be a quick one where I wanted to focus only on these ratios and tell you how to get the unit circle. So thank you for watching, and I'll see you in another video.